Shortcut rules. Shortcut rules. 1 through 6 and 15 through 22, what questions do you have? 4 and 5. Thank you, Joyce. Why? That's my number 4. Did you look at, you might have looked at the quick review number 4. I'm going to do it anyway, just as refresher. Can I what? Oh, the mirror board link? Yeah. Six or 15 through 22. Number 2. Y equals x cubed over 3 minus x. And they asked me to find dy dx, which is the same thing. Remember, get used to all these different notations. Those are all the same thing. So same process here, right? Multiply by 3. Well, what's 3 times a third? Right, because x cubed over 3 is the same thing as 1/3 x cubed. What do you mean that's a thing? Tell me what you did. Tell me what. I just wrote my question. So this would just be x squared minus 1. I was running with that. What? Yeah, because, okay, so this is an exponent of 1, this is an exponent of 3, right? If I bring that 3 around, if I said 3 times x cubed over 3, but then I change this to a squared instead because I subtract 1, right? Is what one of the rules? Yeah, that's that x to the n becomes nx to the n minus 1. That's derivative. Well, and if you had done that, which you can, it would be a lot of work, but you could do derivative of the top, which is 3x squared, times the bottom, minus the top, times derivative of the bottom, all over the bottom squared. Right? Derivative of the top times the bottom. Which would be 9x squared over 9, which would be x squared. So it still works, it's just more work. All right, so the derivative of x to the first power, so that's 1 times x to the 1 minus 1, right? So that would be 1 times x to the 0. So for these, make sure you do simplify these. Make sure you do the simplified derivative. That's probably my fault for telling you never had to simplify anything. And you'll see why when we get a little further. You'll want to, it'll make less work for you. Give me another one. How about number 5? Did y'all get number 5? So y'all got 5, but you didn't get 2? Come on now. X cubed over 3 plus x squared over 2 plus x. So derivative would be, if I multiply by 3, right, I get x squared. Multiply by 2. Okay. Well, that's all of it. Remember, this one I'd already done in number 2, right? So same concept here, 2 times x over 2. I changed this to a 1 because I subtract 1. Well, the 2's cancel. So you got them right, but you don't remember what you did. I was smart when I did it. No, it's not smart when I look at it. Y'all just have to brush these cobwebs off because. Let me put. Meaning what? Yes, because remember that property, if I have a polynomial that's split up, right, that if I want to find the derivative of f of x plus g of x, then I do the derivative of f of x plus, this could be plus or minus, the derivative of g of x. You want to split them, it makes it easier for you to split them up and do them separately. As long as you're adding or subtracting, you can do that. X squared plus x plus 1. Let's try another one, because I can see what kind y'all are messing up on here. I'm going to make it a little bit harder, though. Find the derivative of y. Y'all are just zombies this morning. Like, I don't even know what's going on right now. If you were evaluating the derivative at a specific point, yes. But I'm asking you for the general form. So it's the same process no matter what's there. It's if you have x to the n, to find the derivative, you multiply by the n in front and then you subtract 1 from the exponent. That's how you find the derivative. Yeah. I know. That's why I was laughing at y'all. What you gonna simplify? Yeah. Well, so if you look at like number 19 through 22, those I would probably, or actually starting with 17, I would probably use the division shortcut. Yes. Sure. Okay, so but you kind of do. Give me one. Give me one. 18. 7. Okay, we'll do 17, 18, and 19. How about that? Okay. 17, y equals, so they asked me to find dy dx. I'm trying to switch up my notation here so you start to see that they really are the same thing. All right, so this is I've got a fraction here, right? So I'm going to use that quotient property. So I do derivative of the top. Well, what's the derivative of the top? 2 times the bottom minus the top times derivative of the bottom. What's derivative of the bottom? 3 over the bottom squared. Well, so now I do want to simplify this just a little bit to get a general derivative equation. Yes, and you'll see why on this one I do need to simplify whenever we get a couple sections later. All right, so 6x minus 4 minus 6x minus 15. I am going to leave the bottom factored. Once you're completely factored in either the top or the bottom, you're really simplified. The top wasn't factored though, right? Is it what? On these, yeah. Well, there was a negative in the middle here. So really that was -3 distributing through to those. Is the way I did it. Y'all ready for another? That's it. Because it's already fully factored. The top wasn't factored, so it wasn't simplified. Let's try 18. Did anybody get these right when you did them, or? All right, find the derivative. C by dx. Or y'all already did it, didn't you? I forget. All right, derivative of the top is, what'd you say? 2x plus 5 times the bottom minus the top times derivative of the bottom, 2x, all over the bottom squared. Yes. So 2x cubed plus 5x squared minus 2x cubed minus 10x squared plus 2x. Negative 5x squared plus 2x over x to the 4th. And I can simplify that a little bit. I can take an x out of everybody. I would stop there. Your book takes it a little further, I wouldn't. I wouldn't split that up. Feel good? About 19. Did y'all get 19? 19 is a product embedded in a quotient. Well, so let me show you. Let me work 19. I figured y'all would. 19 and 22, I think, were probably the hardest. Of everything you had going on here. So let's see, y equals x minus 1 times x squared plus x plus 1. Now, if you wanted to multiply that top out before you started, so that the derivative was a little easier to take, you could have, but that's going to be messy. I would probably leave it written as is and do derivative of the top. Well, when I do derivative of the top, I have a product, yes? So here's what I'm going to do. Derivative of the top. Derivative of the first times that you're facing C. I'm keeping this, because remember I'm doing derivative of the, if I make this, let's call the top U and the bottom V, okay? Then I would have to do the derivative of the top times the bottom minus top times derivative of the bottom all over the bottom square. So the derivative of the top is going to be kind of complicated, so I put it in a bracket. All right, so derivative of the first times the second plus the first times derivative of the second. What's the second? 2x plus 1. All of this is just the derivative of the top. So do derivative of the top times the bottom minus feel like that's in the way. The top, so x minus 1, x squared plus x plus 1, times derivative of bottom. Derivative of the bottom, not x cubed, but 3x squared. This is derivative of the top. This is the derivative of the top times the bottom minus the bottom, minus the top times derivative of the bottom. That's what I was trying to get to with the UV, but I'll just write it like that. And then the bottom is x cubed, and of course I have to square it. Which ends up being a crap ton of algebra, right? A lot of bleh. All right, so I got x squared plus x plus 1. Now I'm just going to start working this out. 2x squared plus x minus 2x minus 1. Oh, x cubed plus x squared plus x minus x squared minus x minus 1 all over x to the 6th. And stuff starts canceling. 3x squared 1, 2x, minus 2x, plus 1 minus 1. Look how nicely that worked out. Times x cubed minus, let's see, x squared cancels, x cancels. So I've got x cubed minus 1 times 3x squared. Now it's something I can work with. 3x to the 6th minus 3x to the 5th plus 3x squared over x to the 6th. I can take an x squared out of everybody. 3x to the 4th minus 3x cubed plus 3 over x. I think I shall stop there. I must have messed up somewhere. They got 3 over x to the 4th. Okay, where did I mess up? Yeah, where did I multiply them? Oh, this is a 5. That's right. There we go. Now it's right. Sorry, rookie mistake. Did y'all see what I did? I multiplied the exponents instead of adding them. I don't think it's negative. Okay. I did too. It's okay. What? So if I had x squared to the 3rd, that would be x to the 6th. But if I have x squared times x to the 3rd, that's x to the 5th. Yes? So what I did was I did this like negative 3x squared times x cubed plus x squared plus x. So you see what I'm saying? I'm in too deep. I got to finish right now. Yes, I just moved that to the front here and distributed the negative. You could simplify it first and then distribute the negative in the end. Yeah. Either way. What else? About 22. Did y'all get 22?
Probably not.
Yeah. After you see how involved they actually were, probably not. If I'm doing 22, I would FOIL that out, top and bottom, before I take derivative, just because I got to. But you don't have to. You can do it either way. That's the nice thing about these is you can do them either way. Which way would y'all rather me do it? Do you want me to derive it as it is, or do you want me to multiply it out first and then? Sure. Okay, so this would be the same thing as x squared plus 2x plus 1x is plus 3x plus 2 over x squared minus 2x minus 1x is minus 3x plus 2. And there's nothing wrong with doing that. If you want to manipulate it first and then work with it, or if you want to work with it and then manipulate it, it doesn't matter. Either way is fine. So now if I do the derivative, I got derivative of the top. What's the derivative of the top? That's right. Times the bottom minus the top. Let's derivative of the bottom. Let's derivative of the bottom. 2x minus 3 all over the bottom square. I'm going to leave that bottom as is right now. I could probably make that x minus 2, x minus 1. Remember the goal, remember whenever we did rational fractions in pre-cal, the goal is to have everything completely factored in order to simplify. So on the bottom here, I might change that to x minus 1, x minus 2, bless you, squared, because some things might cancel out. But other than that, I wouldn't do anything else with the bottom. The top's what I'm really going to have to work with. All right, so up top, 2x cubed minus 6x squared plus 4x plus 3x squared. I love these. They're so satisfying. Minus 9x plus 6 minus 2x cubed minus 3x squared plus 6x squared minus 9x plus 4x minus 4, minus 6. All over, and I'm going to write this way, just in case some factors cancel. How'd I what? How else are you going to multiply it out? I told you in the beginning, though, remember, it's the algebra, not the cal. What are you doing? You look like you are up to no good. What did you do? What did you do? And you have paper towels in your hand. Did you spill something? You got up. Max moved. All right, now I have, let's see, 2x cubed minus 3x squared minus 5x plus 6 minus 2x cubed. I just combine like terms. Negative 6x squared and 3x squared gives me negative. Yeah, I just simplified this one. 4x and negative 9x is negative 5x and 6. This one, 2x cubed plus 3x squared. This looks exactly the same, or almost the same. And then when the negative multiplies or distributes through there, minus 2x cubed minus 3x squared plus 5x plus 6. So we're going to practice more with these rules, 'cause I figured y'all didn't remember them. Negative 6x squared plus 12. I think something's going to cancel. Yeah. Maybe not. I could take a negative 6 out of the top. How you going to make that? I'm going to stop there. Can't do anything else. If that was an x minus 2 instead of an x squared minus 2, that would be lovely, but it's not. So, such is life. What do you mean? Mm-hmm. What do you mean f plus h? Oh no, that would be so long. I don't know that you could do that. I don't know that I could do that using the difference quotient on something like this. It would be hard. I could, but it would be hard. You'd get into common denominators, least common denominators, combining rational functions because you started with a rational function, taking the limits as you go to 0 on all that. It would just be, bleh. Yeah. I would always do the shortcut. The only time you're really going to use difference quotient is in a multiple choice situation where they're asking you the definition, because literally that is the definition of a derivative. It's kind of like when you learn multiplication, you learn that multiplication is really just a bunch of addition, right? 2 times 3 is really 2 plus 2 plus 2. And knowing that helps you understand everything else, but you really never use it that way again. Same thing with those. You already practice something a little bit different? What if I asked you? Y'all okay? Y'all do not look okay. You do not sound okay. You do not seem okay. Do you need a break? Not really new. I'm giving you the given part of it. I haven't given you the problem yet. Let's assume that u of 2, so I've got two different functions here, u and v. Let's assume that u of 2 is 3. The derivative of u at 2 is negative 4. V of 2 is 1, and the derivative of v at 2 is 2. And I want to find the derivative of the following. This, by the way, is number 24 in your book. You'll have number 23 for homework, which is parallel to this one. They're exactly the same, just different values. So the first thing I want you to do is find the derivative of u over v at x equals 2. I'm just telling you this is the function. All right, first of all, I have a fraction here, yes? How do you find the derivative of a fraction? Derivative of the top times the bottom minus now if I ask you to find this at a specific point, the specific point being 2, that was all given to you. Look up here. This is just a plug and chug problem. What's the derivative of u at 2? Negative 4. The derivative of u at 2. So negative 4. Why isn't it what? Find the derivative at x equals 2. Right. So this is just the derivative in general. Now if I want to find it at 2, so this is really going to be derivative at 2 times derivative at, or times function at 2. Maybe I should write it out like this for y'all. Now it's literally plug and chug, match them up. Derivative of u at 2 is negative 4. What's v of 2? 1. Minus, what's u of 2? 3. What's the derivative of v at 2? 2. I got to stand up a second. What is the function value v at 2? 1 and then squared. Right? Negative 4 minus 6 over 1. This is the same thing. This is still more derivative rules. Derivative rules practice. That's what I labeled mine. All right, how about this one? What if I take those, yeah. I'm trying to zoom in, I don't know why. How about you try this one? Derivative of, oops, oh, I'm going out of order in this. This is not actually b, but it's still. U times v. Try that one. At 2. Derivative of u times v at 2. Mark that out. Too much? You think it's too much? Just a fidgeter. I got negative 4 times 1 plus 3 times 2. You do definitely memorize those rules. You won't have any, I mean, you will have them memorized soon enough to we'll do them so much. It's not like you'll need to put them on note cards and go, oh, I can't remember, because you will. How about, I'm going to skip to part B here. Yep. Tell me when you're good. That was quick. Sure. All right, if you can do this one, you got it. Find the derivative at 2. Not actually as hard as it looks. What not? It was like that. This is actually sickeningly easy when you see it if you start getting bogged down on it. Yes. That other 2v has a U in the middle of it. The answer to that is no. No, Robert. You love to cancel stuff out, then, don't you? What's the derivative? Because this is a polynomial, right? I can split this up. I can say the derivative of this minus the derivative of this plus the derivative of that, right? What's the derivative of 3u? 3. Right? 3 minus 2 plus, where are you getting that? We've already done the derivative of uv, right? The derivative of uv is 2. No sense in doing double work. Yes, it is. It was 2. It's negative 4 plus 6. Only because 2 times 2 is the same thing as 2 plus 2, and that's the only reason it would work in that one. No. Okay, so let's pull this over to the side and let's look at a minute. Derivative of 2uv by one of those properties. Which part don't you want to? Hold on. Halfway. Okay, so we can't do it like forget what I just said. Forget what I just said because we're taking it with respect to x, not with respect to u, and we haven't taught. Okay, so we're gonna do this variable and this variable are different, so I can't just say it's 3. Right, right. So this is 3 times the derivative of u minus 2 times the derivative of v plus 2. Is that what you said? I thought. Okay, I'm sorry. Thank you. And then the derivative of uv. But we can use everything we've already done as we. Wait, what? What's wrong? What is that? The derivative of 3u, because that constant rule, I can bring that out front and then just do the derivative of u. Same thing with this one, and then same thing with this one. I just pulled those out front, and the reason I did that was because I already have, if you look, I have the derivative of u, I have the derivative of v, I even have the derivative of uv. Right, like 96, sorry. So 3 times 3 minus 2 times derivative of v. Which one did I do? Oh, I'm getting flustered now. Thanks, Joyce. Yes, derivatives here. So 3 times derivative of u would be negative 4. Minus 2 times derivative of v would be 2. Plus 2 times, this number's still right, 2. Yeah, no, I'm not doing so hot this morning. That's got to be what it is. Negative 12. I apologize for that. But that's a good lesson learned, look, because the variable here doesn't match the variable here. We shall get to that though. Ooh. How much? Ooh. Find DYDX. I should give someone $30 if they can do this one.
All right, if you're giving me $30.
No, I don't have $30 to give you. I said I should. No, I said I should.
Oh, -2,000.
No, I'm solving this. I'm doing it right now. You owe me $30.
Unfortunately, photo math does not work as well once you get past like halfway through free cal.
Well, you know that the
We're not doing that. That's BC topic.
well, it's not symmetric.
We don't offer BC. BC is more advanced. We just don't.
Like, I think I might.
7 minus 2 over x.
7 minus 2.
I think I might have like
I don't think that's it. Let me see your one. All right, so let's talk through this because this comes up a lot, and this is one of those little properties you have to remember. It's not a trick question, but you have to kind of rework it just a little bit before you can actually do it. In other words, I know properties. Are you okay? We don't care. We don't care. Cough. Yeah. Cough on Robert. Okay, so square root of x, write it with an exponent. You put what? 1/2, not 1/2 x, but just x to the 1/2. Agree or disagree? Right? That sunshine. Remember the sunshine? Ah. So okay, so there's a 2 outside here, right? An implied 2 because it's a square root. So to make this into an exponent, I do 1 divided by the number that's the root. So because if there was a sunshine shining, right now the 1's in the shade and the 2's in the sun, so when you switch it, you put the 2 in the shade and the 1 in the sun. The fraction bar, the house, the fraction bar. Okay, whatever, but still, whenever I say sunshine, y'all know what I'm talking about. Change the form, right? All right. So now that it is a base with a fraction, with an exponent, I can easily take the derivative, right? Because the property is still the same. Bring it around, 1/2 times x. What's 1/2 minus 1? Negative 1/2. Now I'm going to have to, I don't like to leave negative exponents, so I'm going to have to move that around. Yes, probably.
Why did you put 1/2 in blue?
Why is it negative 1/2?
1/2 in the front and then subtract 1 from the, still that same property. Contain your excitement, Robert. Simmer down. How about the derivative of 3x squared? I hope you can do that without thinking too much. 6x. 6x So, all right, how about the derivative of x to the negative second? Negative 2x to the negative 3, because I subtract 1, right? And I got a negative and a negative, so this is going to be plus 2x to the negative 3. Now, I'm okay with you leaving it like this. What your book will do and what they'll do on the exam and multiple choice is you'll have to recognize that this is the same thing. And here's where, this is why things get so confusing sometimes. 1 over 2 times the square root of x. In calculus, it's okay to leave that radical in the bottom. Oh, 1/2, and then this one moves down to the bottom because it's negative. Okay. Now, for your test that is open-ended, FRQ or whatever, I'm okay with you stopping here, but in a multiple choice situation, I can guarantee you they're going to give it to you that way. So you have to be able to recognize both ways. Let me give you one to try. Stop with the excitement, Joyce. I can't take it. Find the derivative. I should make this a little bit hard. I don't know.
All right. You got it.
You won. Oh, I don't know. I haven't looked. We're gonna definitely be in the section again tomorrow too. I was looking for homework problems for tonight, so that I, but in the process, also think about what you have tomorrow. So. Okay, I'm ready. Y'all ready? I meant to pause that recording while we were. All right, derivative here. Oh, I thought you said. Okay. Derivative of the top. 2 times 1/2 x to the negative 1/2, right? You just band-aided a number of times. That's the derivative of the top.
Would that go to 1 x
What?
2 times 1/2 x and then how would that go to 1 x?
Yes. Yes. I'm just showing all my steps, so everybody says, where did it go? All right, that's the derivative of the top. All right, so this is really, right, this is 2x to the 1/2. Which, are you good? All right, derivative of the top times the bottom, and I'm gonna keep everything kind of the same form. I'm gonna change them to exponents here so that I'm.
Oh, I definitely. Wait, why is it not?
All right, how do you find derivative of a quotient? You do the derivative of the top times the bottom as is minus the top times derivative of the bottom all over the bottom squared. What's the square root of x squared? X. Well, that's nice. This one I made up off the top of my head, so if it comes out really nasty, I'm really sorry. Yeah. Some of them I get from your homework, some of them I make up. All right, let's see what happens. I'm just going to rewrite this so you can see it a little better. X to the 1/2 times x to the negative 1/2 minus 2x to the negative third minus 1/2 x. I'm just rewriting. I'm not even multiplying anything out yet. I am going to change that to 1/2 so that I'm in the same form all the way across. Now I'm ready to start distributing. What happens there? X to the 1/2 times x to the negative 1/2. I'm multiplying, so I add, and I get x to the 0, which is 1. Minus 2x. Now my question is, what is 1/2 plus negative 3? Negative 5 over 2. Negative 2.5. All right. 1/2 minus 3. Y'all okay there? I was just showing what these two added together are, how I came up with that. Because whenever I said negative 5 over 2, some of you went, what?
Oh, yeah.
Okay. Same thing, and then as a fraction. Okay. All right, so here we go. I'm going to leave this minus. I'll worry about that in a minute. I'm going to go ahead and distribute here. A half times 2, 1. And then same thing happens here, right? I'm adding these exponents, so I just get 1. One half, so this is a plus right now, 1/2 x, negative, this is a negative, 1/2, negative 1/2 minus 2. Negative 5/2 again. Quite convenient, right? Everybody gets over x. Now I am going to do this. The ones cancel. And then those are like terms now. That's exactly right. Negative 2 minus 1/2 would be yeah. Hey, that's pretty cool. I couldn't have done that again if I wanted to. Which one? This one in the beginning? Because in the beginning, whenever I multiplied that negative 2 around, it made it negative there. What did you say? I didn't hear you. That was fun, wasn't it? Well, because that x is technically negative, what would really happen is that would come down to the bottom. You want me to show you? Right, bring it around to the bottom. No, but still ask what it would look like. That's 1, so that would be x to the 7/2. Negative 5/2 square root x to the 7th. I thought it was wonderful. All right, so you have 20 minutes left. I'm going to give you time to work on your homework and get started on it so you don't have as much. What you are doing tonight. Tomorrow we'll talk about tangents and second, third, and fourth derivatives. All still within this same section. Can y'all believe it? That's a lot, right? All right, we're going to start on page 129. It'll go through page 1, I don't know, something. Didn't I already print it out? I feel like I did. 13, 14, to page 130 something, 131. 13, 14, 23, 29 to 32. This looks like a lot, but it's really not. Half of these are multiple choice, but I had to pick and choose which ones. I'm going to give you a hint on 46 and 48. They look awful. Okay? Recognize constants, because what's the derivative of a constant? 0. And they will give you this big, long, nasty formula, a whole, this much of a word problem. But if you pull the, and this is typical, I give you these because this is typical on FRQ. They'll give you all this gobbledygook that you really don't even need. You got this equation here that's embedded within the problem. You pull it out and you do this simple little manipulation with it and you're done. And that's kind of the same way that these two go. So you just have to realize what it is you're trying to find. You have to make your way through all the garbage to get to what